All right, welcome to Tissue Types, Take 2. Epithelial is one type of human tissue, and that's the one you see first when you look at someone, because that's your skin. And anything that covers your body or lines the body. That includes all the way down your throat, the stomach, intestines, out the poop chute. You have simple squamous epithelium. Simple means one layered. Squamous means squashed or flat. You have simple cuboidal, which is again one layer and cube shaped. Simple columnar, one layer but column shaped. The bottom row is the stratified. Stratified means layered. Honestly, there's only three of the four at the bottom are stratified. The stratified squamous epithelial is stratified, and you can see they flatten out as they reach the top. That's your skin. The flat cells eventually slough off to make dust. The stratified cuboidal, it's more than one layer of cuboidal. This is the last time you hear me talk about that in this unit, so I won't test you over it. The pseudostratified columnar looks stratified. Pseudo means false. It looks stratified, but it's not. And I'll use that snot alliteration later. Pseudo, falsely stratified. If you look, every one of those cells is a long column, but the nuclei are not on the same layer, so it looks stratified, but it's not. Transitional epithelium on the right side is stratified mess. It's stratified, but it really doesn't have any rhyme or reason. But it does transition from that to where it squishes out way flat. It looks like stratified squamous, kind of, but even flatter when it's full, like when your bladder's full, when it stretches. All right, these notes will be linked here when you get to my website. Right now, it just says YouTube. There's not a link there, but it will be. Epithelial tissue functions. Protect. They're the first line of defense. Bacteria are trying to get in you every day. They take little magic carpet rides on your dust, your cells that slough off. Some do make it through, but not many. Those that make it through, our white blood cells take care of. It serves as a barrier, the first line of defense. It protects, I guess the number one protection is you're not getting scraped up underneath, because if you scratch, even if you scratch yourself, you're scratching cells off, but you got a few layers there that you're scratching off. You're not going all the way down to where the blood is. Permit passage of material. Epithelial tissue in your lungs is very thin and allows oxygen to go through. Epithelial tissue lines blood vessels. It allows water to go through. For secreting substances such as sweat glands. Yes, your glands, your sweat glands are made of epithelial tissue. That's good to know. To absorb substances. Again, the lungs absorb the oxygen, microvilli in the intestines, little tiny, very thin folds absorb nutrients. So classification and function, once again, simple means single layer. So here we have a cross section. I got on paint and pretend this is a cross section of a tubular, like a blood vessel. Oh, what the heck. Anyway, that's the top view. I will not show you that picture because from the top view, yeah, you can tell they're flat, but that's hard to tell. There we go. The cross section on the side is a tube. It's cut, and now what's inside that, my blue lines are supposed to pop in now, not before. But that's a cross section of a gland duct. So simple cuboidal cells make up a lot of your ducts, like sweat gland ducts. There they go. Now it's popping out so you can see it. So now you can really visualize that that's a cross section of a duct. Stratified squamous epithelial. The slide on the left is excellent, and the ones on the right at the top is your hand-drawn diagrams. Be familiar with both of them because they're both pretty easy to see. That as the cells get further away from the blood source, they start dying, and they fill up with keratin protein. So that top layer 5 is what's called stratum corneum, or layer corneum. Corny means horny because the bull's horns are made of epithelial, are made of keratin protein. That stratum corneum is all mainly keratin protein filled. So strata is layers. is for protection. Squamous epithelial, flat, the squashed ones. They help like for breathing your alveoli in your lungs, oxygen, water, etc. diffuse through those. Stratified squamous epithelial. Scan, there's a beautiful slide. Again, this slide could be on the test because I don't like it. No blood vessels touch the outer flattened dead cells. So blood vessels come up to right about down here. They shoot up in these little dermal papillae. They pop up. So they feed the lower cells. But as those cells get pushed upwards, they start dying, flattening out, and producing a lot of keratin protein just to fill up and interlock. And you can see at the very top of here, this little cell is getting ready to break loose and become dust. Yeah, 90% of the dust in your room is pretty much you, your old self. Cuboidal, this one's been differentially stained, so it really pops. Your test is going to be black and white, so don't get used to this. Again, cross-section through these ducts for absorption or secretion. Some protection, but not really much. Kidney collecting duct. Yeah, these are probably through some nephrons here or something. Columnar is your tall column, nerve absorption in the respiratory tract, and they produce mucus. So here's some practice. Number one, probably the best picture I can find of simple squamous. Number two, you guessed it, simple. You just saw that. So simple cuboidal has more organelles for absorption and secretion. This is a super close-up under microscope of microvilli in your digestive tract. So those little folds, the villi folds, if you look in closer, they've got even tinier folds of these microvilli, and they're made up of some simple columnar epithelial. So you can see that the nuclei are all on the same level, and the columns all look pretty much identical. And the stuff between them here is probably digested food getting ready to be absorbed. Pseudostratified, and I throw in ciliated. I throw some alliteration here. Pseudostratified ciliated columnar epithelia. It's false layered. The reason I throw cilia in there is because, yeah, most of them have cilia. You can see the little cilia at the top here, very fine. And they move the mucus down the throat. So stratified squamous epithelium, there's two main types. You can see here both types. Around her face, keratinized, so it's full of keratin protein. It's thick and sloughs off pretty easily. The lips is very thin, non-keratinized basically. There's not much keratin protein, just some very thin layer of epithelial cells above the stratified living. So you can see they're redder because of the blood vessels. And inside, yes, the non-keratinized lining the mouth. You don't need the keratin protein lining the mouth because, go backwards here, on the outside, you're going to dry out. On the inside, you're constantly salivating and your mouth is constantly wet, so you don't need to fill it with shingles of keratin-filled cells, kind of like the shingles on a roof of a house, to seal that moisture in. Your mouth's constantly being moisturized by saliva unless you got meth mouth. Stratified squamous diagram. Here's a nice diagram you practice with in class. And it's got all the labels there, so you can see the base layer attaches it to connective tissue below. Connective tissue mainly connects, and there's a bunch of different types of connective tissue. We'll talk about that. So transitional epithelium. This is a good picture here. This is from the KU Med School. This is a free one. You can see this purple part up above is the transitional. It looks like gobbledygook. What happens is it's stratified and stretchable, and it will stretch. I'm trying to find a picture here with stretching. It lines the urinary bladder, and here we go. So here's it relaxed. The upper part is the transitional. So when your urinary bladder is empty, it's relaxed. When you fill it up, it stretches out like that. So it's stretched. So here's a diagram for your review. Simple super diagrams. Practice for yourself. Simple squamous, simple columnar, squamous. All right. Some free surface characteristics of epithelial tissue. A, they're smooth. Your blood vessels are lined with simple squamous epithelial. It reduces friction. It's kind of like Teflon coating on a pan. The blood cells can zip through there unimpeded so they don't stick together. They help make up microvilli, and we saw that earlier in that little cross section to increase surface area. Boom, here's a nice diagram of microvilli. They form cilia for movement of mucus. These are electron micrographs, otherwise you won't see them that clearly. They're itsy bitsy tiny little tendrils sticking up that move and sweep the mucus down the throat. E, gland types. I'm not going to get into all the different types of like ACE&R and stuff. I'm going to talk about your gland types like sweat glands and stuff. So, exocrine glands, exo means to exit, so they shoot outside the body. That's like your sweat glands, saliva glands, everything goes onto the surface. Your digestive glands, they shoot all that digestive out into the small intestine. Someone's banging on my door. I'm ignoring them. Endocrine, or into the blood. Endo, into. So, thyroid gland, adrenal gland, pancreas, your sex glands, all put hormones into the blood so they fit the body. So again, exocrine onto the surface, endocrine into the blood. Connective tissue. I didn't think I'd get this far. Three major components of the extracellular material. You have protein fibers. Extracellular means outside the cells. So you have protein fibers, such as collagen, which is very strong, which helps make your tendons. You have reticular fibers, which are shorter, make it springier. And elastic fibers, which are very coiled, like springs. So your ears, they'll stretch when get pulled, and that'll rebound back to place. Your nose will point back to place. Another thing is you have what's called ground substance. They call it ground substance because it's basically a shapeless background under a microscope. It has no form or shape really. People are really persistent about knocking on my door. Then finally you have fluid between cells. Your blood is a type of connective tissue, and its main extracellular component is fluid. Okay, types of connective tissue cells. You have anything that ends in blast is a builder cell. So osteoblast is a bone builder. Chondroblast is a cartilage builder. So chondro means cartilage, osteo means bone. Bob the Builder, blast, BB, think BB, alliteration again. Bob the Builder, blast, Bob blasts, but he builds, okay? So blasts build. Clasts are shaped like a C, like Pac-Man. Clast cells break down. In your body right now, your osteoblasts and osteoclasts are both reforming your bones depending on your posture, so have good posture. If you're a weightlifter, your osteoblasts are putting more bone on than your osteoclasts are chewing away. But they're both always at work. Just depends on how much calcium is needed in the body. They're chewing the calcium store away. Site means it just maintains. When osteoblast has built bone around it, it is locked in its little lacuna, or little hole there. Now it's an osteocyte, and it just maintains its little home there. He's maintaining it. He's keeping it clean. Macrophage, macro, big, phage, eater. It's a white blood cell. They've stained it in purple so you can see it eating a little yellow object, probably some bacteria or something, I don't know what. Phageo, eat, macro, big. Mast cells, these are all blood cells now. They're part of connective tissue. Mast cells release chemicals for inflammation. You'll see this again this spring when we talk about blood. Functions of connective tissue connect. Okay, they enclose and separate tissues and organs. They connect. Bone to muscle. Think of your Achilles tendon. It goes from the muscle to the bone. You can feel that. And with that, I'm going to stop and answer the door before this jerk pounds the door down. Enjoy part 1.